Hello everyone, I'm Natalie Kunzman, MD, and today I thought we'd talk about COVID antibodies because I've had that question a few times from patients this week, so I thought we would dive into it. Now, we need to know what an antibody is and how it may interplay to our current knowledge and understanding of the immune system, and to do that, we need to understand that there are two major branches of our immune system. One of them is considered the innate immune system, and this would include everything from our skin barrier, our mucus protection, the acid in our stomach, a cough that may help eliminate a perceived foreigner. And these immune systems in the immune cells in the innate immune system start secreting interferon and interleukins, which are some of those cytokines we have been learning about, and that will indiscriminately attack a target. And when it indiscriminately does that, it might harm our own cells in the process, and our own cells can get quite inflamed because of this direct hand-to-hand combat. And again, this happens when one of the invaders in our system, such as a bacteria or a virus or maybe a parasite, this happens when the first time we've seen this because we don't have any memory cells at all to help go after this attacker very specifically. So this is what we call a cell-mediated response as opposed to an antibody-related response. Now, the second arm of our immune system is the adaptive immune system. And the adaptive immune system is what a lot of us understand as the antibody response to a particular foreigner. This is where our immune system can actually develop memory from previous exposures to previous pathogens. And now this immune system has developed a series of steps that can help go wipe out the infectious source. And the system in the adaptive response does take longer to recognize the pathogen and go get some of those memory cells, but now it involves some T helper cells, other numerous immune systems, and these said B cells, which are making the antibodies. Now, antibodies are protein-based, and they're going to go on a search and attack mission, and they will chemically attach to the foreigner, and they chemically attach in a lock and key mechanism, and it will help engulf the foreigner so that those other immune systems know what to do with it and can actually destroy this enemy. Now, as we get older, some of this memory system becomes one of our prominent modes of fighting. Now, when we are younger, we have mostly the innate immune system. So we'll use COVID as the example. And right now we're noticing that children and infants seem to be virtually unaffected by this virus. And part of that is, this is a new virus, it is novel, our immune systems have not seen it yet, so we don't have that memory system or that adaptive system to go after the foreigner, the pathogen, the COVID-19. So we need to make heavy use of our innate immune system, which actually has native or naive or new T cells that can indiscriminately immediately go to the site and go on the attack. Now, those new T cells are made from the thymus gland. The thymus gland is huge in a youngster because they are cranking out and making a lot of these T cells. But as we reach adulthood, this thymus virtually doesn't exist anymore. So we can see that the young host that is intact has a quicker ability to fight this virus. Now, this will bring us to the 5 types of antibodies that we have, which will help explain this a little bit further. So there's 5 types of antibodies, and we can call those immunoglobulins. So that's why they are designated as IG, immunoglobulin. So we have IgA, IgD, IgE, which is common in a flagrant allergy response, IgM and IgG. So we're going to focus on the IgM and the IgG. So for the purpose of this discussion, let's talk about IgM first, because it is the one that gets to the battlefield first. And it happens to be one of the largest of the antibodies. And we can find it circulating in the blood and lymph because it uses the blood and lymph to get to the sites that it needs to get to. So you could see why this uses an efficient transport system to get to the pathogen quickly. Now, as IgG antibodies are being made, now they are smaller, but they will provide a much more long-term benefit. IgM gets there immediately. It's an aggressive attack early on, but it wanes quickly. Then IgG needs to kick in, which can give us our much longer, long-term relief and memory of this pathogen. So when we are diving into the testing of COVID, I need to remind everybody that the initial testing that we use to diagnose if you are positive or not comes from RNA sequencing, because the coronavirus is an RNA replicating versus a DNA. It's an RNA replicating virus, so we go right in to the nasal passages, which has the highest amount of the virus appreciated, and we are measuring how much virus or how many RNA or how much RNA particles we can find. This diagnoses whether or not you have the active infection or not. Of course, there are false positives and there are false negatives, and there are different companies that make these assays, and there are different concentrations of the virus depending upon where you are in the illness, if it's in the beginning, the middle, or the end. And then, of course, we have technical issues where each practitioner may use the nasal swab a little bit differently. But suffice to say, nasal swab or oral swab can be used for RNA sequenced particles specific to the coronavirus. But where the antibodies come in, they aren't very effective in helping us determine whether or not you are in the throes of the illness or not, because it takes a while for those antibodies to become present, or to what we might call seroconvert. It may take up to 2 weeks in the throes of an infection to actually be able to measure the IgM antibodies, which are the first ones that you're going to measure. Now, again, if we are picking up IgG antibodies, these are later on in the infection or long after the infection, and may take up to 12 weeks to be able to see. So we would use this in the capacity for a patient who maybe months ago wasn't sure if they had the illness and would like to see if they had an exposure. Of course, we can use these antibodies to donate to help make vaccinations or further research studies, but it's not very useful in the early throes of determining whether or not you have the illness or not. Now, as a reminder, antibodies are the exact way that an immunization works. So what we are trying to do is many times give some particles of the virus, most times it's not a live virus, in hopes that our adaptive immune system can go make some antibodies. They will provide some of the IgMs, and then they will provide the long-term relief with those IgG antibodies. There is also immunotherapy out there that is reserved for a very rare situation where the exact immunoglobulin or that IgG can be given through an IV when a person is gravely ill to fight that particular virus. And we don't have such sophistication just yet with COVID-19 in this pandemic. So, quick reminder, we are in a pandemic. We are feverishly working on COVID-19 vaccinations, but some of these viruses can become very smart and they may mutate every year because they are trying to bypass our adaptive immune system so that they can still survive in the host. So if the virus will mutate from year to year, some of those nice protective antibodies we have may not be effective. Only time's going to tell with this. So if we manufacture an immunization against this year's COVID-19 as it is, and it mutates, this is why a new immunization may be needed the following year, and so on, just as we see with the influenza immunizations. I believe that over time, this virus is rendered less capable. So this is the first season of COVID. I believe we are in the last wave of all of those people who have been exposed and didn't succumb to the illness. And by the time we hit the first quarter of next year, this is the second season that COVID-19 is in the world. And think of all those adaptive immune systems, all those people that have had exposures, that have been sick, and the virus comes around again. It is rendered far less capable than it was the first time around because we have an innate immune system and an adaptive immune system to take care of it. So I would just say to you all, please stay safe, keep your immune system strong, and I hope you have a much better understanding of antibodies as it relates to COVID. Again, I'm Natalie Kunzman, MD. Until we meet again, be well.